Okay, we're going to jump into lesson 14.2/14.3, which is going to be on geometric sequences and exponential growth and decay. It's going to be broken into two videos. So this will be part one, which is going to focus on the geometric sequences portion, a continuation of last video, and then we'll kind of get into exponential growth and decay in the next video, which would be more 14.3. So we talked a little bit about geometric sequences in the last video. This is going to be sequences where we have a common multiplier, right? A common ratio, so we're multiplying by the same number over and over and over again. And we've got two different types of rules to define these sequences. The first one is the recursive rule, okay? And so we've got that listed here, right? And we saw this in the last video as well. And there's just one piece that you need to know for the recursive rule, and that's just what the R value is, what the common ratio is, right? So hopefully we're remembering that. R is the common ratio, or whatever you're multiplying by. And sometimes R is not super easy to find, right? Sometimes you can't figure out what R is just by looking. And so you can use this formula here to find R if it's not obvious. And we'll get to a problem where we'll have to do that, so you'll kind of see what I'm talking about. But I'm just going to put a box around it so it brings your attention to it right now. So to use this recursive formula, a couple things we need to list. First, just like when we did the arithmetic sequences, we need to identify what the first value is, what f of 1 is. So I'm going to say, okay, f of 1, the first term of my sequence is 1 over 25. So that's the first piece there, right? And that just comes from whatever the first term in your sequence is. So f of 1 equals 1 over 25. And then we're going to go back up and use this formula from the green box here. So it looks like this. We've got f of n equals, okay, it tells me R, so whatever I'm multiplying by. It's not super obvious in the beginning of this sequence here, right? We got 1 over 25, 1 over 5, but as I move along here, I can see, okay, well, it looks like I'm multiplying by 5, so my R value must be 5 times f of n minus 1. Okay, and then that's it for that piece. And then there's going to be one more part that they're going to have on your homework, and that's going to be define what n can be, right? So what can n be here? And for our equations, n has to be greater than or equal to 2. That's going to stay the same the whole time, okay? Because if we put in a number that's less than 2 here, it'll ask for f of 0. We don't have f of 0. We don't have f of negative 1 and those things. So just keep in mind that n is always going to be greater than or equal to 2 for our purposes. And so there's kind of three pieces here, right? We've got the first term, we've got the actual recursive formula, and then we've got to state that n has to be greater than or equal to 2 for this formula to work. And then there's one more piece that I want to show you here, and that's that sometimes they're going to use different notation. So we're using f here, but you can also use a different form here, which is going to look like this. So a sub 1, right, would be another notation that we could use, and in this case it just means the same thing as f of 1. And then they would write it as a sub n equals 5 times a n minus 1. So that's like little subscript down there. Okay, so it's just new notation, and then this part would be the same, n is greater than or equal to 2. So it doesn't mean anything different, it's just a different way to write it. Just want you to see it so that you're not confused the first time you notice it. So that's the recursive form. We also have the explicit form, which is more helpful to us because it allows us to find any term in the sequence. Okay? And so for this one, we've got two pieces here. We've got a, which is the initial value, or the starting term, right? First term of the sequence, initial value. And then we've got R again, which we know as the common ratio. And if we have those two pieces, then we can write this explicit form of these geometric sequences. So we can do this pretty quick here. It says f of n equals a, which is my first term. That's going to be 1 over 25. Times r, which again in this case is 5, and then n minus 1. And then once again, they could use different notation, write this as a sub n equals, same deal here, 1 over 25 times 5, n minus 1. So it's the same thing there, they're just using a instead of f. All right, moving to example 3, this is what your homework will look like here. So we want to go through a couple of these problems. Same idea. They're giving you a sequence here. We know this is a geometric sequence because we are multiplying by some number. In this case, it looks like we're multiplying by 6 each time. Okay, and so then they have a couple different boxes here. It says the recursive rule is A1 equals, I'm down here right now, A1 equals, well, the first term here is 4. And then it says an equals blank times an minus 1. Well, remember, when we're doing the n minus 1, they're looking for whatever r is here. Okay, so that needs to be whatever r is. And in this case, we can see that r is 6. And then we said this is for n is greater than or equal to 2. And that's just going to stay the same for all of those. So that's the recursive rule. Now moving to the explicit rule. Remember, it starts with, up here, it starts with a and then has r. Okay, so down here we've got a, which is the initial value of 4, and then r, which is the multiplier, the common ratio of 6, and we're done there. Moving over to the letter B. Okay. Same idea here. We've got our A1 value as negative 16. That's the first term there. And then whatever we're multiplying by, this one's not quite as obvious, but we go from negative 16 to 8 to negative 4, right? And remember, if you can't figure out what r is, you can always use this formula. R is F2 over F1, right? You only have to use this if it's not obvious. Okay, and so for this one, we've got 8, that's the second term, over F1, which is negative 16, that's the first term. And that tells me my r value is negative 1/2. Some of us may have been able to see that without using the formula, and that's fine too. And that's for n is greater than or equal to 2. Okay, and then again here we've got a and we've got r for the explicit rule. So a is the initial value of negative 16 times r, which is negative 1/2, and we're good to go. Keep it going here to letter C. Once again, I can't quite tell what my r value is here, so I'm going to use that formula again. R equals F2, the second term, divided by F1, the first term. That's 4 over 6, which is 2/3. Okay. And now it says A1, well, that's going to be 6. And then we have AN equals R times AN minus 1. So R is 2/3, that's what we just found. And this is for n is greater than or equal to 2. And then to the explicit rule, a, initial value, that's 6, r, common ratio, that's 2/3. And we've got those two pieces, and we're good to go. Moving to example 4, it says find the requested term. So they want the fifth term here. I'm going to use the explicit rule to find this. Remember, my explicit rule looks like this. AN equals a times r n minus 1, and I need a and I need r. So a is the first term, that's going to be 1, and r is whatever I'm multiplying. In this case, looks like I'm multiplying by 8, and so my formula looks like this. An equals 1 times 8 to the n minus 1. So I got my explicit rule there, but they're asking for the fifth term, so what I'm going to do is find a sub 5, which just means that I plug in a 5 to n, and then I can go ahead and evaluate here. This is going to be 1 times 8 to the 4th power, and so 8 to the 4th power, I might have to do some calculator work there, and I get a to a sub 5, the fifth term, is 4,096. So I want to point out that to complete this operation here, first you would do 8 to the 4th power, and then you would multiply by 1, which in this case doesn't do anything. But that's the process, right? We got to do the exponents and then the multiplication, just like PEMDAS. And then we'll go to the next one here. So again, we need a and we need r. Well, we can see that a is 16, the first term. R, not quite as obvious, right? So I'm going to do the second term, negative 3.2, divided by the first term. Okay, that'll always give me my r value, right? I don't always need to use it, but in this case it's going to be helpful. And that tells me that r is negative 0.2. And so my formula looks like this. A sub n equals 16 times negative 0.2 n minus 1. But remember, they're asking for the 7th term, so I'll go ahead and find a sub 7. So we get 16 times negative 0.2, 7 minus 1. Well, of course, that's going to be 16 times negative 0.2 to the 6th power. Okay, so first I'm going to go ahead and do negative 2 to the 6th power. And then after that, I'm going to multiply my answer by 16. Okay, so first I'm going to do this piece here. Then I'm going to multiply by 16. And when I do that, I get 0.0002048. And just look out for what they're asking you to round to when you get to this on your homework, okay? And that's it. Thanks for watching.